Okay, so derivatives of inverse trig functions, we're ready to apply these. Now, I reminded those that were in here yesterday, arc sine is just a different way to say sine inverse, right? Whether you see the -1 inverse symbol or the word arc, both ways it means inverse, no difference. Neither one is, I don't know if there's even one more preferred or less preferred. I mean, they're both equivalent.
There's nothing like that. Do you want to put your date on there?
I can. Are you saying you want my date on there?
I just know you always do
It's
it,
anyway.
and then my girlfriend, he didn't do it today.
Why?
Oh, that's a darn.
I do that. I just kept doing that to bug you.
Not really.
I think it looks great.
I was
I like
commenting. I think it's good.
Okay.
It's great.
I just
Okay.
put it up there and it
So, these formulas, okay. Now, realize this U prime business. I mentioned this yesterday, right? This U prime is just representing the chain rule. Okay? So, if you don't have anything on chain rule, that's just going to be ones or -1s in all the numerators. Okay? That's just the chain rule. So, and I'll kind of explain that as we go through. So, let's look at example 2a. I agree. Y equals sine inverse of 5x. And we're being asked to differentiate. Sorry, I have some extra information written in my example, and I was trying to decide why. Interesting. Okay, we're going to use the formula. And I think what some of this I wrote out is if we want to actually kind of derive it as we go, but I don't want to do that. So, y equals sine inverse. We're trying to find the derivative. So you can write this as y prime, or I'm actually going to write dy dx. The derivative of sine inverse of something. Okay, well, what is the derivative of sine inverse of something? We're looking right here, yes. So we're going to have a fraction. For beginning's sake, I'm just going to put a 1 on top, okay? If you want to get fancier than that, we can. We'll worry about the u prime. I'll explain here in a moment, okay? We'll worry about the u prime here in a moment. Now, square root of 1 minus, what is our u? 5x, right? So realize, and I'll even write it over here, u is our 5x. So that means we're going to be doing 5x quantity squared, right? So square root of 1 minus u squared. And then what I usually think is, okay, what do we do with chain rule? Then it's times the derivative of the something. Well, what was our something here? The derivative of 5x is 5, okay? Chain rule, we usually think of writing it afterwards, right? Where is this 5 supposed to be according to the formula? That's what goes on top. And you can go ahead and put it on top. And that's what I'll kind of start doing in the future. But I'm just trying to get us going here. And I'll be honest, when I know, if you ask me what's the derivative of sine inverse, I'm not going to say u prime over the square root of 1 minus u squared. Because I know that no matter what, I have to apply chain rule if it's needed. If you ask me the derivative of sine inverse, I'm going to say it's 1 over the square root of 1 minus x squared. But just knowing that chain rule may apply. Okay? Now, other than that, it is a cleanup thing.
Mr. Sellers, if you could please go to the auditorium. Mr. Sellers, please go to the auditorium. Thank you.
If we clean this up, what's our cleanup going to look like?
5 over square root of 1 minus 25x squared.
Yep. As I said, you don't really have to be here for what we did yesterday to be able to do yesterday. I mean, it was a good breaking point because now we're just starting the application process. So, okay, questions there? Okay. B. Let's try a tangent inverse.
Can we rewrite that first?
We can. At some point, you're going to want to think about it. And I guess what I'm going to think about over here what do we know? Like this is going to be where u goes, right? And this is square root of 2x plus 1, or in other words, it is
2x to 1.
2x plus 1 to the 1/2? Okay. So, dy dx is equal to, okay, tangent inverse.
Oh my gosh, how many?
So,
Looking at the wrong one.
the bottom is 1 plus u squared. What is my u? The square root of 2x plus 1 squared. And then, yeah, this is where I'm just going to put the 1 on top, and I'm going to do my chain rule after the fact on this one because of what's happening here. Okay, when we do this chain rule, here, we can even go ahead and kind of do the chain rule over here. If u is 2x plus 1 to the 1/2, du represents derivative. What's the derivative of this?
2.
No.
Half. 1/2.
1/2.
1/2.
Derivative of something in 1/2
Plus
is 1/2 2x plus 1 to the negative 1/2 times,
Two.
there's the 2. So the outer piece is something to the 1/2. Subtract the 1/2 out front, subtract the 1/2. Then it's times the derivative of the inside, which is the 2. If we clean this up a little bit, what do you see happening?
The two's cancel.
2's cancel. And what about a 2x plus 1 to the negative 1/2?
1 over 2x.
1 over 2x plus 1 to the 1/2, yes? So now, the purpose of me doing this is, can I just go ahead and write that over here? We've kind of done our side work. 1 over 2x plus 1 to the 1/2. We kind of already did the work off to the side there. And this is why I'm not putting it in the numerator, because you'd have fractions within fractions, and it's just easier to think about it multiplying like this. Okay. There's some cleanup we can do. 1 over what?
2x plus 1.
1 plus 2x plus 1. And I agree. That is going to become 2x plus 2 here in a moment. Times 1 over
The square root of 2x plus 1.
square root of 2x plus 1. I was just trying to look. The cleanup is minimal. There's not, come on. There we go. I'm going to make it one big fraction. 1 over 2x plus 2 in parentheses times the square root of 2x plus 1. And why did I put my 2x plus 2 in parentheses? Because it's that whole quantity times the square root. And the only other option I have, 2x plus 2 has a GCF. And I'm not saying you have to by any means, but 1 over 2 times x plus 1 times square root of 2x plus 1. Okay? So, again, the other one is perfectly fine as long as you can identify the equivalents. Okay. Catching on a little bit. Because these are not the easiest thing. Okay, continuing. C, y equals arc cosine of x squared. What is this really saying? Cosine inverse of x squared, yes? Okay, so that's what you're really looking at there.
U equals x squared.
So, dy dx. And yes, if you need off to the side, can you do that off to the side? Yes. I don't know if that's what Kylie was writing or not, but she said it, at least. So, u equals x squared. That's my inside piece, right? So what's the derivative of cosine inverse of something?
Negative 2x.
over. I have the square root of 1 minus x to the 4.
I was just gonna ask, is it multiplying whenever it's on the outside? Oh, well, sorry. It's 2, so it doesn't help me figure it out. Whenever it's on the outside,
It's a
you multiply.
multiplication.
Thank you.
When it's a power raised to a power, it is a multiplication. Is that what I'm trying to simplify there?
Sorry.
Okay, so now, so it's the -1 over square root of 1 minus u squared, so that's x squared squared, and then times 2x, because that is the derivative of x squared. Okay, what's your cleaned up answer look like?
Negative 2x.
I'm assuming that's what my answer key is going to have.
Hopefully.
Now realize, I'm not taking these square roots because I can't, right?
Right.
I can't square root 1 minus x to the 4th, even though they're both perfect squares, because they are added or subtracted. Okay? So don't try and, that'll get you in trouble. Okay? Derivative of sine inverse of x squared minus 1. What you got?
1 over square root of 1 minus x squared minus 1. Minus the quantity.
Are we there? 1 over the square root of 1 minus the x squared minus 1 quantity squared. And then times, basically you're doing, if u is x squared minus 1, then du is 2x. Okay. Now, how much does this clean up? We're going to be doing some cleanup there. You here take the test or do some calculus?
Test. Pass.
You're going to pass on the calculus? Okay.
You can take mine. I'll take your test. You did the calc. I'm good.
Yeah, literally.
What is it?
Algebra 2.
Oh,
Oh, never mind.
Never
Maybe
mind.
not. I actually liked algebra 2.
We can
The calculus.
It is a quadratic chapter though, so
Yep, I'm out.
yeah, and you can use your blue paper. So Okay.
I remember when we could use papers like that.
the days. I remember when we could use a calculator.
Yeah, literally.
I think we still have. I think this next test is still no calculators, if I recall. Okay, 2x is on top. Yes.
Yes.
1 minus x.
To the 4th.
X to the 4th
Plus
plus 1.
No, because
No.
you have the minus 2x.
Get the formula now.
It'd be x squared minus 2x.
Oh,
Dang it!
X
Really,
squared
guys?
I am disappointed.
Serious.
You should be.
x to the 4
You're just
Dang it!
minus 2x squared
Plus 1.
plus 1.
Yeah. That's what I got.
I'll just write down those guys.
Gosh, Amy. You should have dropped it.
Well, we have an option here. Now, okay, process this through, folks. If you FOIL this out, this is x to the 4th minus 2x squared plus 1. Why is that not what I wrote over there?
Because it's the subtracting quantity.
It's 1 minus all of this. So if you want to, I mean, you could do 1 minus parentheses x to the 4th minus 2x squared plus, nope, I had that wrong, plus 1. You could write it like this first.
Okay.
It's how many steps do we want to skip, but how much is going to mess us up if we skip those steps, right? Okay. Let's clean it up again, please.
Let's cancel.
Oh, yeah. I was gonna just leave it like this. I was like, I don't see anything with it.
1 minus 1 is 0. I'm not sure why you would do that piece. Now, there's a cleanup step you could take, and I want to show it because I could see a multiple choice question doing this to us. Okay, what do you see happening within that square root in the denominator?
There's two.
And there's.
Well,
You can factor it out.
okay,
Factor out a square exponent.
go the GCF route.
Oh, you can take it out and then.
Okay, so I'm going to take this in baby steps here. Within my square root, there is a GCF of x squared. When I factor that x squared out within the square root still, I'm going to reverse this so my negative isn't first. I'm going to say 2 minus x squared in parentheses, as opposed to negative x squared plus 2. Same thing, right? Now, that 2 minus x squared is stuck under the radical. However, that square root of x squared comes outside, and the square root of x squared is x. Now, here's the deal that I want to show you. It would be likely that they would put that x in absolute value, and doing that because it came from under the radical. Okay, has to do with, I'm trying to remember how our rules go back from algebra 2. It's not the plus or minus because it's coming out of a radical, but it's the idea that we can't have the square root of a negative. And if it would possibly put us in that situation, we can't do that. Okay? So, I'm not opposed to you leaving it the other answer. However, I don't feel like I'm doing my job if I haven't shown it. Fair enough? Okay. Are we having issues?
No.
This is lovely.
What are you laughing at?
Okay. Let's try E. See if we can keep this one straight. Okay. Derivative of tangent inverse is 1 over, is it 1 plus x squared? Is that the formula?
Yeah.
Sorry.
Yeah.
These formulas are ones I'm weak on when it comes to memory. So, okay. 1 over 1 plus x squared, right? But what is my x here? Or my u, I guess? Cosine x.
Times root.
Yeah, I wrote mine as cosine squared, but you could write it as cosine x quantity squared. Times
Sine. Negative sine.
No, negative sign.
Negative sine.
derivative of cosine is
Negative sine squared x. Right?
No,
Cosine squared.
negative sine x.
that's where.
I have that written down. Don't know why it says
Okay. Cleanup wise,
There's not much you can do, right?
there's not much you can do other than make it a fraction. Negative sine x over 1 plus cosine squared x.
I was eyeing that, hoping it'd be a 1 minus cosine squared x.
If it was a 1 minus cosine squared x, well,
Maybe negative 1, wouldn't it? Oh,
No.
no, it'd be sine squared.
Yeah.
So, okay. F.
U equals e to x.
Okay. My inside piece is e to the x. So the derivative of sine inverse of something.
1 over square root of 1 minus e to the x times e to the x.
You guys with her?
I hate
1 minus e to the x quantity squared times e to the x. Now, when we clean this up, I do want to clean that denominator up a little bit. Okay. E to the x does go on top. Square root of 1 minus, what is e to the x quantity squared?
e to the x.
E to the 2x.
squared.
E to the 2x.
E to the 2x. Because when you're doing a power raised to a power, you're multiplying. This was Sophie's, am I multiplying those 2's or adding those 2's earlier? This is the same thing, we are multiplying. Yeah, it is. It's a mess, we just leave it.
Without
Okay. Continue along. Until you get to homework, right?
Right. And are we gonna have to memorize these?
So my recommendation, and I mentioned this yesterday, but I definitely need to say it again with everyone in here. Usually what I feel like I'm told is that when it comes to the inverse trig function derivatives, you need to know sine and tangent. is what I've always been told. Now, my thing is, if you know sine though, you know cosine because it's just the negative. Okay, it's never been stressed or really suggested that the inverse trig functions need memorized. Okay, so I think if you know your sine, cosine, tangent.
And then whatever it's inverses, it has extra. Except for cotangent.
Yeah, as I said, those aren't the ones that we're going to worry about too much. So, okay, example 3. Okay, guys, you know what to do here. I know it's a new example, but I know you know what to do. Find an equation of the tangent line. Been there, done that, right? Equation of the tangent line to the graph of the function y equals arctan x over 2 at the point 2 comma pi over 4.
Which is
Find a slope. Which is find the derivative. As I said, been there, done this, right?
The equation we use.
Okay, now arctan is tan inverse of x over 2, if you will. If you need that. dy dx. Okay, what's our tangent inverse derivative?
1 over.
1 plus e squared. Or plus x squared.
1 over 1 plus, officially I would say u.
So 1 plus x over 2 quantity squared.
Times.
Oh, what's the derivative?
1/2.
Quotient rule?
It'd be 1/2 x.
Would you take the derivative on top of the bottom?
Yeah.
U is just x over 2. 2 is a constant. Think of that as just 1/2 x.
So
The derivative of 1/2 x is 1/2. Would the quotient rule technically get you there? Yes, but it is big time overkill. Fair enough? Not going to say it wouldn't get you there, but.
So it'd be 1/2 times.
Okay, so 1.
Right?
What did I?
No.
Okay, 1 over now. What do I want to do here? Do you want to distribute the 2 also as we go?
Yes.
Okay, if we take this 2 and distribute, 2 times 1 is 2 plus. Now, okay, side note because I know we need it. What is x over 2 quantity squared?
X squared over 2.
It's x squared over 4 for what I'm asking.
Oh.
And then when we multiply that by 2,
X squared.
x squared over 2. Fair enough?
Shoot.
Oh, that.
I might have to take a few
I'm like,
more
where did the
steps
other
to do this
two come from?
correctly.
That's distributed, right?
Yes.
Okay.
That is me taking this 2 here and distributing it to the 1 and to the x over 2 quantity squared.
Okay.
Does that make better sense?
Yeah.
2 times 1 was 2. X over 2, we had to square that first, which was the x squared over 4, and then times 2 makes the x squared over 2. Now, are we going to leave an answer with a fraction within a fraction? No.
Yeah.
You want to, but we're not. What am I going to do to get rid of that fraction within a fraction?
Multiply by 2.
Because the denominator is 2, and I want to get rid of that, the denominator within the denominator. I want to get rid of this 2 right here, so we multiply by 2. If I multiply the denominator by 2, you're multiplying the numerator by 2.
2 over 4 plus x squared.
I agree with the numerator.
4 plus x squared.
Okay. We good? Yeah. I'm not saying it's not what you said. I just hadn't processed that far.
Okay.
I'm like, wait.
As in, no, I agree with the numerator. I just hadn't yeah, it didn't have it in my brain, so I couldn't.
I
Okay.
just heard Doug whisper.
Now, this is our dy dx, yes? Okay, what do we need now? We need to plug in
2 pi over 4.
We need to find what the derivative is when evaluated at 2 comma pi over 4. Now, in this case, you only have to plug in the 2. could there be times where you have to plug in a y value also?
Yeah.
There could. So, 2 over 4 plus 2 squared?
Yeah.
2 over 8.
2 over 8. 1 over 4.
Okay?
And then
Yeah.
you do the y. 1, 4. 1, 4.
Quantity x.
Oh.
Plus 5 over 4. Up the line twice.
Jazz hand.
Jazz hands. I like that one.
Okay. And I'm going with we're okay there because I heard a variety of different voices responding to me.
Yes.
So,
For once, Kylie didn't say DNA.
okay. Example 4.
Wait a
Find dy dx when tangent of 4x minus y equals 4x.
Nothing.
Hint, all trig fun. Whoa. Oh, okay, just hearing the answer. I was like, whoa. Hold the phone.
All
I thought it said
trig
appear at
functions.
first. I was like, whoa.
All trig functions will disappear in your answer.
I don't even know where to start.
Do we need to
Never
get,
mind.
we need to equal y, so
Yes.
Yes.
switch the, oh wait. Oh yeah, we could do that, right?
That's gonna cause a lot of problems.
Yeah, that's
though.
what I
Good
thought.
What
job.
was the inverse?
Okay.
So we.
And that just equals
Because.
negative 0.
But it's not. So you
Danny.
flip them. Because it's inverse.
Oh,
So
I thought you
when
might
you
be
have
for
the
Danny.
arc,
No, I'm pointing at Hannah. Hannah's on the right track here.
then you have the arctangent, and then you can do all that to find the derivative.
Okay, so
And it should get rid of her trig point.
the problem is, in order to do this derivative, I don't know, maybe you could do implicit differentiation and it would work. I don't know. But based on the fact that we are in an inverse trig function lesson, okay? Right now, the tangent of 4x minus y equals 4x. I cannot solve for y the way this is because that y is stuck inside the tangent, okay? So,
Oh, I forgot the tangent was a part of it.
yeah, tangent is a part of that. So, inverse. What does the inverse of something do? It takes your input and your output and it switches them. So if instead of writing tangent, I write tangent inverse of 4x, and that's going to be equal to 4x minus y. Okay? And that's what an inverse trig function will do. She did it a different way. She took, and this works too, and I don't know, well, at least I'm guessing she did this because I have it written in my notes as an option. But the other thought is to get rid of a tangent, you can take the tangent inverse. And the idea is when you take the tangent inverse of a tangent, these two cancel each other out and you have 4x minus y. And then you would have tangent inverse of 4x as well.
So,
Which it comes out the same. Exactly. So, okay, we need to solve this for y.
This girl's on cocaine. This girl,
She is.
This girl's on cocaine.
Solve for y, please. My brain is adding y and subtracting tangent inverse 4x.
4x minus tangent inverse 4x.
Fair enough?
Yeah.
Mhm.
Can we do that all in one step in our heads?
Yes. Sort of.
Sometimes? How's that?
With the teacher just
There we go.
stamping there, yes.
And homework at my house? Probably not.
Yeah, no. That's miserable.
Okay. Now we're ready. We have it y equals, so let's try some derivative work. dy dx, derivative of 4x, 4, minus derivative of tangent inverse of something.
Over 1 plus 4x squared times 4. Right?
Amen.
Try.
Amen.
Yeah.
That's what I got.
Yeah.
Unless I did something wrong, but you know.
I got
Oh my
something.
gosh,
Like
I cannot do that today, I swear.
Okay. I didn't think I did anything tricky. You guys seem to be following.
Mm-hmm.
I think Hannah read off the derivative of the tangent inverse there. It was 1 over the 1 plus the quantity squared times the derivative of that, 4x, which was 4. I just cleaned this up, put the 4 on top. 4x quantity squared is 16x squared. I did a double take when I looked in my notes because I have my final answer as 1 fraction. Okay. As in
4 minus.
common denominator.
Oh, what?
Okay.
1 plus 16 extra.
No, it would be like,
You have to like multiply.
Yeah.
It'd be like 4.
So
times, yeah.
you would be doing common denominator would be 1 plus 16x squared, right? So in order to get 4 to have that, it's currently 4 over 1, right? And you would have to multiply 4 over 1 by 1 plus 16x squared over 1 plus 16x squared. Whoops. And then we still have the minus 4 over 1 plus 16x squared. Like, this is something you need to be able to do, right? Get this common denominator. Didn't say it was going to be pretty. So,
4 plus 64x squared.
okay, yeah, if you distribute here, 4 plus 64x squared, technically all over 1 plus 16x squared, right?
Yeah.
Can I go ahead and put the two fractions together?
Yeah.
Minus 4 over 1 plus 16x squared.
You're like 64x squared. 1 plus 16x.
When you clean up that numerator, 64x squared over 1 plus 16x squared.
That's it.
That's it. We weren't trying to write the equation of a tangent line there. We were just trying to find the derivative. Okay. Example 5 when you're ready.
Ready.
Let g be the inverse of the function f of x equals 2 cosine x, where x is between 0 and pi. Find the value of g prime of 1.
Thank you.
Well, it has to be at 0 and at 5.
No, it's just saying that that is where x is defined to be. And I'll explain there's a reason x has to be between 0 and pi. We're going to be doing some trig function stuff.
So
And if you don't have a certain range of where x is going to be, we could have lots of answers.
So
So,
I thought you would have to evaluate at 0 and evaluate at pi. So I was wrong.
so yes, g is defined to be the inverse. So g is f inverse, which means they're asking me to find f inverse of 1. F inverse derivative of 1. Okay, so you have to go back to lesson 3-4 here. Derivative of the inverse. We have a formula. Yes?
1 over
I didn't memorize these things.
1
It's hard to say
over.
when it's not.
What's a big memorizing part?
Now, was everybody here?
F.
Hold on.
Is it Monday?
It
It was
might-
not Monday.
No, it was Tuesday.
Well, I'm trying to figure out, was everyone here when I talked about IDDI?
Yeah.
Yeah.
Sophie probably wasn't.
No.
Okay. So the idea, when you're trying to remember this formula, okay, this here is the inverse, right? And then the derivative. So when you go to do the denominator, if it's ID here, then in the denominator it's DI. So it's going to be the derivative
Of F.
I know, I'm struggling here. F was the derivative of the original of the
G
of the inverse. Oh my gosh, I can't. Here's my thing. I'm going to do better. I struggle with the G's for some reason. F prime of F inverse of X.
Yes.
Okay? That's the way we learned it, right?
Yes.
Inverse derivative, and so then notice here it is derivative, then inverse. A little tip in helping to memorize.
You need your primer.
Now, with that in mind, here, so this is the inverse derivative. Now it is supposed to be derivative inverse. My brain, I don't know, the G's mess me up. I'm not sure why. They shouldn't, but they are, for whatever reason. Okay. Let's see. 1 over f prime. Oh, this isn't really supposed to be an x on the inside. What is it we're really using?
1.
This is really a 1. So, I need to know g of 1.
It's 2.
You have to find F inverse.
Yeah. Well,
Oh,
not really.
Well,
I didn't do the inverse, so I just kind of went for it.
If we're looking for g of 1, then that means f is the inverse, right? Because basically when we're looking for g of 1, we're looking for f inverse of 1, yes?
Yes.
So then that means f of something equals 1. If I'm thinking f of something equals 1, what's going to be the easiest thing to do?
2 cosine x.
2 cosine x equal to 1.
Divided by 2.
So I'm looking for when cosine x equals 1/2.
That is.
And this is where specifically they define us on the interval from 0 to pi. So I only want answers when cosine is 1/2.
I couldn't figure out which one was on the bottom. Wait,
What now?
no, is that one on the top?
No.
No, it's pi over 3.
No, it's pi over 6.
Yeah.
Which one's first? Does
I
it go
see.
pi over 6?
Pi over
3?
6.
Oh.
It goes smallest to largest. Pi
Okay.
over 6, pi over 4, pi over 3. So don't worry, my brain was processing. Oh, wait.
I do it live. Oh God.
No, yeah, that's what I said. Oh god.
Oh, nope, I reversed my chart.
Pi over, I thought pi over 3 was on top.
You were right, is what I'm.
You were. You were.
Don't ever
Then
tell
you're
Sophie
right.
that ever again.
Well, I just did because the rest of us were wrong.
I didn't say an answer.
Mario was wrong.
I was wrong.
Yeah, that happens.
I don't like it.
Okay,
But I was probably.
my apologies.
Makes you feel any better. I didn't say there.
If you didn't say anything, fine. If you said pi over 6, own up to it. We were wrong. Pi over 3 was right. That's, you know.
So then you
Are you guys okay with my pi over 3?
Yeah.
Sorry, my brain
G of
struggled for that moment too, for whatever reason. Normally I'm good with the trig, but not
Cosine
today.
is 1/2 at pi over 3.
Yes, right?
Right.
So now, what does this mean?
you
F
plug in
prime
G
of pi over 3.
If we were trying to find g of 1 is what? Well, we just found f of pi over 3 to be 1. So
G
g of 1 is
over 3.
pi over 3. Oh my goodness. My bin Q is glitching out on me.
That's a lot.
Okay. Whew. Now, 1 over f prime of pi over 3.
Yeah. It's a constant.
There's no x.
What?
What are you talking about?
No.
F of x is 2 cosine x. What are we talking about here?
What?
Oh.
F of x is 2 cosine x.
You're not taking
What
the
is
derivative.
Stupid.
We are taking the derivative of f prime,
No, I'm.
but you take the derivative when there's x before you plug it in.
That's true.
You don't
No.
take a derivative with an x value plugged in. Never, ever, ever. So what's the derivative of 2 cosine x?
Negative sine x.
Negative
2
2
negative 2 sine x.
So we want to find f prime of pi over 3 of negative 2 times sine of pi over 3.
Negative 2 times root of
Oh my lord.
But the 2's cancel. Yes?
Yep.
Well, that was not fun.
We didn't do a single inverse there, did we?
No.
Okay. I bet, you know what, I bet there's a way that you could have, but we didn't, and that's fine.
And that's okay.
This is the way I have it done in my notes, so we're going with it. Okay, one more. I'd hope to give you some work time here, so. Find the slope-intercept form of the tangent line at pi over 4 negative 1 to the graph of x squared plus x tangent inverse y equals y minus 1. Round to 3 decimal places.
I don't like this.
Okay. If we are looking for slope-intercept form of the tangent line, they give us a point. What do we need?
Slope.
We need a slope. In order to get the slope, we need to take the derivative. Okay, so this is not something we are solving for y. It's just not happening, okay? So there's 2 y's. One of them was in an inverse trig function, so we're using implicit differentiation, okay? The derivative of x squared. In other words, we're taking the derivative in this form.
2x.
Derivative of x squared is 2x plus
That's product rule.
my next piece is x times tangent inverse y. So this is a product rule, yes? Derivative of x is 1, keeping the tan inverse y. Product rule says we then add, and now we're going to keep the x. Derivative of tangent inverse y, 1 over 1 plus u squared, which is y squared,
And then dy dx.
times the derivative of y, which is dy dx,
Equals
equals
dy dx. Or
derivative of y is dy dx minus the derivative of 1, 0. Okay? This is taking us back to like lesson 3-4, I think. Implicit differentiation. We have dy dx's. We want them
on the same side.
on the same side. So I'm going to keep my 2x and keep my tangent inverse y. On the right, I already have dy dx. And then I'm going to subtract. Can I put this together as one fraction?
Yes.
We're going to subtract x over 1 plus y squared dy dx.
Take out the.
Divide by x.
Okay, I've got to factor out my dy dx first.
Yeah.
Oh, shoot. Mario.
So for me, I am factoring out dy dx on, I have to be on the right. When I factor dy dx out, I'm going to have
1 minus.
the 1 minus x over 1 plus y squared. Now I'm ready to
Divided.
solve for dy dx, which is going to be the 2x plus tan inverse y over 1 minus x over 1 plus y squared.
Yep.
We have our derivative, as fun as it might be. Now, what do we need?
Plug in the.
Plug in the.
We need the slope, which means we need to evaluate our derivative at pi over 4 negative 1. And this time I do need both x and y, don't I? Okay, so 2 times pi over 4 plus tan inverse of negative 1 over 1 minus pi over 4 over 1 plus negative 1 squared.
Yeah.
That's fun, isn't it?
Wow.
Discussion.
Now,
Thank God for calculators.
I have at this point plugging into the calculator. And here's the deal. We technically could do all of that and come up with an answer in terms of pi. But on the flip side of this, there's a calculator symbol,
Yeah,
which means very likely
it says 2 decimals.
rounded 3 decimal places. They want a decimal answer here. So, everybody, I would highly recommend you try this because it's a calculator trick, essentially, isn't it? I feel like it's, are you smart enough? Are you smarter than the calculator? Are you smart enough to enter all of that jazz?
No, not
I
right
think I did
now.
already.
Take advantage of your fraction bars, right?
Mhm.
The alpha fraction.
And honestly, there's some of this that you could do in your head,
No.
but I'm not, just because I know some of you would not.
Oh my god. Fractions within fractions.
Within more fractions. You must be about the same spot I am. Oh, shoot.
Oh shoot.
Okay. Sophie, quit repeating me.
No. I don't know where I'm Okay, we're good. We're good.
What you got?
No.
Actually,
No.
actually not.
Yes.
Yes.
And what'd you get? That?
1.293.
I'm almost there. I just got a little stuck.
You scared me. I thought I did.
No, you did.
I'm not gonna write out the whole decimal. Minimum 3 decimal places, right?
Yes.
Okay, when I'm talking AP. So, now with that in mind, write our equation.
Like
Oh.
1.293. That's plenty of x minus power 4 minus 1.
However, this is not gonna get you full credit.
Because it's point slope or slope intersection.
That's point
So it's y equals mx plus b.
What do you plug in?
You're not plugging anything in, you're just trying to go for mx plus b form. And this would be a calculator trick again, right?
Yeah.
I don't have the steps written out in my book, I just have an answer then at that point. But I would, because what are you doing? You're multiplying 1.293
I don't know what I did.
times the
Pi over 4.
negative pi over 4,
Um,
right? And then you are subtracting 1 from that.
negative 2.06.
Yeah. That's what I got.
Okay. Less than 3.5.